Problem number 42, I just didn't have enough room on the worksheet itself. So I did take the liberty of doing the first part of it because basically a copy of the last problem. But I did want to show you something new, and I'm hoping that you'll take the time to learn this. It'll be very helpful on your final exam if you're able to manipulate your calculator in such a way that you can figure out how to do these problems differently than the way we did them when we went through the parametric equations section. So anyway, part A was just to come up with the parametric equations, did that. Part B was to figure out how long the ball was in the air, did that using the quad program. Okay, but now for part C, when is the ball at its maximum height? I wanted to show you something that I think is pretty cool. Now that you know derivatives, if I were to graph y1 on my calculator, and if I did y1 as negative 16 x squared plus 135 multiplied by the sine of 20 times t, again that's 20 degrees, plus, oh sorry, that's supposed to be an x, plus 5, if I do that, then on my calculator, this x right here, x equals the time on the calculator. So when I'm reading my calculator, I need to make sure I keep that in mind. When I read values for x on the calculator, I know this can get kind of confusing when you're just doing this for the first time, but try to be patient here and try to really understand how you can use your calculator as an effective tool to help save time and to help you find the right answers in an easier way. Now that you know calculus, you're not required to use the pre-calc that you learned when you did the parametric equations. And you might think, well, why did we learn that? Well, there are some certain things that you can't use calculus for when you're doing the parametric equations, but on the same token, you'll learn more about why when you get to calculus. So nevertheless, you can actually answer this question, part C, when is the ball at its maximum height, using your calculator and using calculus. So what I'm going to do is I'm going to set up this function y1 to represent the height of the ball at time x. And x is what I have to plug into the calculator. And so if I go to my y1, I can see that's the function that I plugged in. Pause the video and plug this in yourself. And then my y2, though, I'm going to set that up and define y2 to be the derivative of my y1 with respect to x at x. And so I can graph not only the function y1, which represents again the height, but I can also graph its derivative. And we know the height is at its maximum when the derivative is equal to 0. Okay, that's what we do. We have a maximum value of the function. Well, when is that going to happen? Well, that max and mins, guys, happen when derivative is 0. So if we draw the graph, figure out, again, pause the video until your graph looks like this. So the parabola here represents the height of the ball at any certain time. That intercept right there is where the height is 0. And in part B, we found that to be 2.99 seconds. Okay, you can't just cut that in half. You could if the initial height were 0, but the initial height was 5, so you can't just cut that time in half to get that. But what I do want to show you is how do we find when the derivative is 0? Well, if we graph the derivative, then we can find the derivative's x-intercept. And that's what we're going to do. Second, calculate 0. That's number 2. Notice that the cursor, though, right now is on my y1. I don't want the cursor on the y1. I want the cursor on the y2. So I'm going to hit my up or down arrow. And hitting the up or down arrow toggles the cursor to the next function. Okay, now notice that the cursor is on the y2 function, which is the derivative function. Okay, and now I move the cursor to the left of the x-intercept, hit enter. I then move the cursor to the right of the x-intercept and hit enter again. Now I move the cursor a little bit back towards where the x-intercept is, and I hit enter again because it's asking me for a guess. And now it's going to give me when the derivative of the y1 is equal to 0. And that's that value right there, 1.443. So at the time, that's, remember, x is time on their calculator. So y1, let's see, when is the ball at its max height? Y1 is a max when t is about equal to 1.443 seconds. Okay, so we just found the x-intercept of the derivative. Okay, now that's part C. So that's the answer. That's the answer. It's over. Part C. That's when the ball is at its maximum height. Well, I want to store that value in A, so I have to go. I should do that again. Second, calculate 0. Left bound 1, right bound 2, and guess 1.5. You can also do it that way. And I'm going to get my 1.44. I wanted to just show you that where to find that value. Oh gosh, are you serious? What happened? Oh, I did the wrong one. Calculate 0. I have to toggle first. And now I go 1, 2, and 1.5. Seriously? My apologies. Second calculate, I'm trying to go too fast. 0. Down arrow, and if I go to 1, left bound, okay, right bound 2, enter, and then 1.5 is my guess. And why didn't it work the first time? I don't know. So there's my x. Now if I second quit, then, and I don't plug any other numbers in, I hit x, enter, and when I hit x, enter, the calculator already had that value stored in as x, but I don't want to leave it as x because anytime I change anything in terms of the function, it's going to change the x. So answer, I'm going to store that in alpha A because I'm going to be using that. Because what I want to know now is I want to know the height at that time. Okay, the height at that time is the y value at that time. Well, I already have the y value stored in there. I don't need to do what I did for problem number 41 and type it all in. Since I already stored my y1, I can go back here and I can say, look, vars y variables y1 at alpha A. And y1 at alpha A is going to give me the y value, meaning the height of the ball, at that time when the height of the ball is at its maximum. And so we see now that the height of the ball is at its maximum when the height is, well, maximum height is 38.311 feet in the air. And so that's part D. So part D, what is the maximum height? Part D would be, the answer would be 38.311 feet. Okay? And that right there, guys, is the maximum height. If I were you, I would make sure I could do that problem using the calculator. And we're going to go ahead and get right into the other stuff here because I want to make good use of this time that I've got. Alright, so numbers 43 through 45, we're solving systems using substitution. No, we're going to use the calculator, okay? First thing we have to do is solve for y. So y squared equals 1 minus x squared, and y equals plus or minus the square root of 1 minus x squared. Okay? And then the second equation is, actually, that plus or minus indicates we have a first equation, a second equation. Then the third equation would be y equals negative 1 minus x. So the positive square root would be your y1. Your y2 would be your negative square root. And then your y3 would be the other one, negative 1 minus x. So that's what we're going to do. We're going to go into the y equals, clear, clear, and let's type that in. So y1 is equal to the square root, positive square root of 1 minus x squared. y2 is negative. Now make sure you use the minus sign down to the left of the enter button, not the minus sign above the plus sign. So there's a negative button and a minus sign. Make sure you use the negative button for that. So the opposite of, and you could say the opposite of y1 if you want to be really fancy. y3 is negative 1 minus x, again, a negative symbol and a minus. And then we know that the function, the first graph would be the graph of a circle radius 1. So we know where we need to be. We don't need to be past, we can adjust our x min and x max and y min and y max accordingly. In other words, okay, we don't need to be past -2 or 2. But there's our top half of our circle, bottom half of our circle, and then we've got this line. We can see that the line intersects the circle at 2 places. Okay, not really sure if, I guess we could replace, we'd look at that. I'll try to save myself a little time here. I know I have a circle of radius 1. I also know that this line comes down here, like it's got a slope of -1. So I actually don't even need to use my calculator. I can see that at -1, 0, and also at 0, -1, I've got my 2 solutions. So I don't need to rely on my calculator for that. But I could, if I were smart, I would type in 0 for x. So 0 plus 1 equals 1, check. And then 0 minus 1 equals -1, check. And then the other one, -1, so 1 plus 0 is 1, check. And -1 plus 0 equals -1, check. So I just checked both of these solutions in the system, making sure that both sets of coordinates satisfy both equations. And they do. That's what you do. You make sure that both of your solutions satisfy both equations. Okay? Let's see if I can fit number 44 in the same video. Y equals 42 over x, and y equals 13 minus x. Okay? So, let's go with 42 divided by x first, and then the 13 minus x second, and just zoom standard just to get an idea. Oh boy. Okay, so now I know if we adjust the window, we can see that up in the upper right hand part of our screen there, which would be the first quadrant. That's where all the action is happening, so we don't need to see any other quadrant. So y equals 0 to y max is 20. Let's see what happens there. Now, what we're looking at here is not a whole lot of detail. So what I would bet, though, is happening is that 6 and 7 and 7 and 6 work. Now, it looks like there's only 6 and 7, 7 and 6. So it looks like there's only one one point of intersection, but you have to be really careful in this. Use your heads here, guys. Don't just try to rely on your calculator, because it's not very clear right there. Now you could zoom in, or actually you could, we could zoom in. Let's just see what we get. Well, let's move the cursor over to the place where all the action is happening here. Okay, we'll zoom in there. There's our curve, and then, it's still really hard to tell. It looks linear once you get to a certain point, but as I said, that's really tough to see. So what you want to do, though, is you want to see if you can solve it a different way by looking here. And normally these kinds of problems are going to generally yield some pretty easy numbers. But if you just look at 6 times 7 is 42, 6 plus 7 is 13, so maybe you might want to do a substitution here, 42 over x. So anyway, you get 6 and 7 as your answer, but then also 7 and 6. Okay, don't be fooled by your calculator. Make sure you think through what you're doing here. Now you could, if you really wanted to, you can go second, calculate, intersect, and then first curve, let's get it in the first quadrant, enter, enter, and then guess is over there. So it gives you 6 and 7. So you'll get 1 just by doing the enter, 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 6 and 7. But then be smart here, okay? 6 and 7, does 7 and 6 work as well? So you have to use a little bit of thinking as well as your calculator. Oh, approaching my 15-minute mark.